Welcome to the another section. So in this section, we are going to learn about how antivirus softwares and EDRs will work. So EDR means the endpoint detection and response. So let me learn about how this kind of defense engines will work. Okay. So before directly jumping into the bypassing antivirus softwares, we need to understand how the defense engines will work. Okay, so let I will open my notepad. I will reduce the theory part here. I will explain most of the things in practical. So if you come to the antivirus engine, so uh, you can have three engines. Okay, not three, four engines. Let we will speak about the static, dynamic, heuristic, and unpacker. So we are going to talk about these three engines. I will give some overall brief of the unpacker. Okay. So let's first talk about the static engine. So before that, I will jump into my antivirus softwares and see how it will detect a threat. Okay. So let I will jump to my bit defender. So you can see. I think there is one protection was disabled. So web protection. So if I enable the protection, my antivirus is showing a green check mark, right? So my antivirus system is active to scan the threat. Okay. So let I will give some job to my antivirus softwares and I will see what will happen in the background. Let Mimi cats. Let download a Mimicat file uh, from a website. Let we will see what happening in the background. So if I click on the download, I can't see the file was downloaded because you see my Bitdefender showing online threat detected. So let's click on more details and we will see what happening in the background. Yeah, here you can see we blocked the dangerous page for your protection, right? So how it blocked? Okay, so let I will take this URL and I will put it in virus total. Let's see how this URL was blocked. So exe. So here you can find some of the antivirus vendors flagged this page as malicious, right? You can see the Bitdefender flagged this page as malware. So now you can understand why this page was blocked. Okay. So I will open my presentation. Here you can see the static signature database. So this is the static engine. So here you have some of the executable DLL docs. It will go to the comparing. Okay. So it will take the executable hash and compare it with the signature database. So this is a signature database. It contains all the malicious hash value. So we will call that as a signatures. It's a pattern. It will compare that executable hash with the database. If the hash matches, it will it will decide whether the file was benign or a malicious. Okay, so let's say you are going to build one of the new malware, and that malware will not be present in the signature database. So you can easily bypass the AV engine, right? Because your signature will not be present in the database. Okay, so if the antivirus software using only the static engine, you can easily bypass the antivirus softwares by creating a new malware. Okay, but wait, uh, the threat actor will decide this kind of things easily. Okay, they will change some of the functions inside their execute malware malicious program, and they will create a new malware, right? So the AV engines decided a new engine to to defend against this kind of threat. Okay, so this is a static engine, and it was good because it detected from a signature. In the same scenario, this was happened. Okay, I just go into the mimikatz.exe URL, and my uh, bit different antivirus software detected that page as a malicious, right? So here you can find it flagged as a malware. Okay, so the same thing. This page was detected as a malicious page, right? So this is how the antivirus programs will work in the background. Okay, let's download. Uh, let's turn off the uh, protections, and we will check what happened in the background if I download the Mimicat file. So you can see the Mimicat file was ready to download, but it's showing it's need permission, right? And if I move to the download, so you can see it was failed, insufficient permission. Uh, let move to the bit defender page, and we will check what happening inside the background. Okay, so you can see some of the infected temp files get cleared because when uh, when I click on the download, my browser application will create a temp file inside that folder. Okay, so for example, the Mimikatz is 64 MB file. So if you want to download that file, so my browser application will create a temp file inside the directory, and it will download the Mimikatz. Okay, so whenever the download was completed, the temp file get changed into the mimikatz.exe. Okay, so this is why the temp file get detected and cleaned up, right? So in my previous things, so here infected file detected. So here you can find the catch files also get cleared because I downloaded the Mimikatz. I tried to download the Mimikatz yesterday. So but it caused the same thing what happening in today. Okay, so you can see some cache files also get detected and cleared because this URL I downloaded in this URL, right? This URL will be saved in the cache file, the Chrome cache file, so that it will get detected and removed. Okay, so think how smart our antivirus software is, right? So if you see the attack timeline, so let I will bring the attack timeline. So here you can find the explorer.exe opened the chrome.exe, and the chrome.exe moved to the one of the URL, and again the threat was sorry, the chrome.exe uh, the catch file get detected as a threat detected, right? The catch file get detected as a threat detected, and you can see the malware is malicious software designed to damage your devices, and it was destroyed by the Bitdefender. Let's see this timeline. What happened? Yeah, let's be time. Yeah, now also some catch files get cleared, right? Because I visited the URL and tried to download the Mimicat file. So this is how your antivirus software will work, and this is for the static detection. Okay, so the static detection, your signature files, there is a signature database, and once your hash matched with the signature database, it will detect that file as malicious. Okay, if it was not if the hash value was not present inside the signature database, the antivirus software will allow that software to execute inside the system. Okay, if it was only using a static engine. So let's talk about the next engine, dynamic engine. So if you see the dynamic engine, so it was a simple diagram. I just put in the slide. Okay, so the same thing, the files will go under the API monitoring and sandboxing. Okay, what is API monitoring? Let's discuss about the API monitoring. Okay, So what is API? I already told what is API and how API work and what is the purpose of the API. Okay, and I showed some of the malicious APIs, right? So if you see the process injection attack, we are using three common APIs. Okay, so one is virtual alloc of, and another one is write proc memory of, and another one is create remote thread of. We are using three APIs for a process injection attack. Let I will go to my Chrome, and let I will redirect to uh, one of the website called Mal API. So let's see what's inside the Mal API. So if you see the uh, website, it will show all the uh, malicious API that was used by the threat actors. Okay, so if you see the injection based attack, you can find um, you can find the virtual alloc of function I discussed, right? Virtual alloc ex of function. So you can see it is often used by malware to allocate a memory inside the process, right? Memory inside a remote process as part of process injection. Okay, it was used for a process injection. We will program this in the red team operation section, how to program a process injection, and we are going to see that in a practical way, how to take a reverse shell using the process injection. Okay, so this virtual alloc and virtual alloc of function was in the Mal API. So this was a common API that was abused by the threat actors to create their malicious softwares, right? So if you go to the other part, let's search for the right control F, right. So you can see the write process memory of it will copy the payload into the target memory. This was the main functionality of the API, write process memory of. So this memory, this API function is based on the kernel 32.dll library. So let's go to the create remote thread of API remote. Yeah, you can see the create remote thread of API is used to create a thread. We already saw what is thread. So thread is an execution object of a program. So it will create a remote thread. Okay. It's also based on a kernel 32 .dll library, and it was basically used for a injection attack. We are going to see this kind of DLLs in our practical section, red team operation. So in the dynamic engine, okay, in the dynamic engine, your antivirus software will monitor the APIs, okay. So for example, which are the APIs are used, if it comes under malicious APIs or not, okay. Plus it will use the sandboxing, okay. It will execute the program inside the sandbox environment. So sandbox environment is like your virtual machine. It will create the own virtual machine, and it will execute that malicious program, and it will check it what behavior it was creating. Okay, what was the behavior of the executable program. So by that you can understand, by that the AV engine will understand whether this application was malicious or a benign. Okay, so this is the dynamic engine. Okay, let me um, so threat actor will abuse this dynamic engine history. Okay, so they will use some encoding methods or encryption method to hide the API monitoring to bypass the dynamic engine. Okay, so then the AV engines think in a smart way to create another engine called the heuristic engine. Okay, so the heuristic engine is like the heuristic engine have a predefined rules. Okay, for example, let I will move to my task manager. So any of the programming programs, so let's see any of the third party program or a system internal. So if you try to access a LSAS, it will malicious, right? So let I will create a militia. Okay. So here you can see the else program. If I create a dump file, so this is a malicious behavior, right? So you can see disinfection in process, right? This is the heuristic engine. So any third-party program or a Windows internals, if it was accessing else as memory, so else as is okay. So else as is basically uh, for a login related stuff. So okay, my V defender cleared everything. Okay, it deleted the task manager completely. Let's no problem. I will. Okay, we cannot find the program in a specified path. Okay, I will install the task manager, no problem. Okay, so in any programs, it will access else as memory. It will be a malicious, right? So else as is responsible for login related things. So the login related credentials will be stored inside the else as program. So if any process accessing the else as program, so it was a malicious, right? So it has some predefined rules, like any of the program accessed else as. See, my task manager is a Windows internals, but it did not care about that program, right? It directly deleted because that was a rule inside the heuristic engine. Okay, any of the program access tells us just block it, destroy the program. Okay, so this is the rule they will write in the database, and if the rule satisfied, it will block that. Okay, so it will decide the malicious or benign. In our scenario, it removed the task manager from my machine. So the sad part, okay, so no problem. I will retrieve it. Okay, so yes, we will see the attack timeline. Okay, application task manager exe has been detected potentially malicious and application path command line parameter /4. Okay, suspicious behavior. Okay, so it was detected as a suspicious behavior. I already said if there is any suspicious behavior uh, inside a program, it will detect and delete that program. Okay, so let's jump on to the next section, next one. We have an unpacker, right? So sometime the malware executable with comes with a packer, like it will use the obfuscation, encryption, and this kind of methods to bypass the AV engine. So your antivirus software have a proper unpacker. So if your antivirus software did not have that unpacker engine, so you can easily the threat actor can easily bypass the antivirus software. We are not going to discuss more about this uh, because I took one of a section, and I will upload the video in the last section in the knowledge base section called bypassing ADR and EVs. S- Sorry, bypass AV and EDRs. You can watch the section to learn more about bypassing the antivirus related things. Okay, so in that section I discussed about the hooking, unhooking, Halos gate, and all. So you can if you are really interested in bypassing antivirus software, you can watch the video. That will be very helpful when you are doing such things. Okay, um, that was 1.5 hours videos, and you can find many things. There was I will prefer you have to complete all the section first, and you can go for that section. Okay, don't jump into the section directly, because you won't get any of things, because that was a little bit advanced section. So my advice is to complete all the section first, red team operations and all, then jump on to the bypassing EDR. Okay, knowledge base section. Okay, so in that section I discussed lot of things, but like incident response and bypassing these EDRs and AV engines. Okay, with the more advanced techniques. So let's APIs. Okay, let's jump on to the protection system. Okay, what are the protection system? Uh, so let's discuss about the protection system. What are the protection system currently we have? We have an EDR. So let's think about what is EDR. Okay, so EDR is a endpoint detection and response. So in this slide, you can see the EDR, one of the EDR named as CrowdStrike Falcon. I took this image from one of the website. So this is the console. This is the GUI interface of the EDR. So EDR is basically a endpoint detection and response system. It will it will protect the user from advanced persistent threats (ATP) and malware through the real-time response. Okay, through the real-time response. Let I will practically explain what is EDR. Okay, so you can see in the most recent detection. So this is the host ID, and if you click on the view details, it will it will show the details. Okay, so it's basically the EDR vendors will install a sensor inside the target machine. Okay, they will install some EDR sensor in the target machine. That sensor will monitor the behavior and the activity of the machine. Okay, and it will send all the logs to the EDR vendors. Okay, for example, if you are using CrowdStrike Falcon EDR, the CrowdStrike Falcon company will install some sensor inside your target machine, and that sensor will monitor your machine, and it will send all the logs to the CrowdStrike Falcon company, and that organization, that team will monitor what happening inside your machine. Okay, so for example, in this scenario, there is a host ID, this is a host name, and there is a tactics command and control via remote. Okay, C2C was detected. If they click on the view details, it will give the details. Okay, this is how EDRs will look like. If you go to the next slide, so you can see you can query the EDRs. Okay, you can query the EDRs and you can see the particular data. For example, if you want a running process for a machine, you can query. If you want a persistence or registry run key for the machine, you can use a query to see all the things. Okay, also it have one of advanced mechanism called as the process tree. Okay, it will show the process tree one by one what happened in the machine. Okay, we already discussed in the process chain. It will show the data like that. Okay, the outlook spawned the winword.exe. Maybe the user opened a macro enabled document or malicious document from the outlook. It spawned the winword.exe, and winword.exe spawned powershell.exe. Absolutely, there is a macro enabled document, so it opened the powershell.exe, and powershell.exe is doing some malicious stuff. Okay, right? So here you can see the in right hand side you can see the host name and all the details. Your EDRs will show like that. Okay, for example, if you are taking some of the other EDRs like Carbon Black or Microsoft Advanced Threat Protection Defender, so that EDR have a separate chart for this. Okay, it's a separate graphical view representation. Okay, so I will go to the next slide. So here you can see the PowerShell command line. You can see the command line also, what command get executed inside the machine. Okay, so this is how your EDRs will operate. Okay, it will collect the logs from the target machine, your machine. So if you are purchased the EDR license, it will collect all the logs from your machine, and it will send that logs to the EDR vendors who is managing your EDR, and that team will monitor your system behavior. Okay, that was the primary responsibility for the team. They need to monitor your system behavior and the activity. Okay, so in right hand side you can see the PowerShell, right? So let's go to the another slide. So the same thing we have. And EDR have one of the advanced thing, the real time response. Okay, so you can so the EDR vendor can query directly query inside your machine. Okay, so in EDR there is a separate options called the live response. If you enabled the live response, so your EDR vendors can directly query into the machine. So it was very helpful when you are facing any of the active incidents. So if you are facing any of the active threat, so at that time, so EDR vendors can directly jump into your machine by using the command and control. So there is a separate tab for a live response. So they will use that live response and directly query into your machine. They can easily delete, kill the services. They can delete the executable. They can do a lot of things. Okay, inside your machine directly without any interactions. Okay, so it's basically they will get one of the command prompt with the system privilege, so they can do a lot of things. Okay, when if you are facing any active incident, so that is called as the real time response. We will call it as a live response. Okay, so this is how your EDRs will work. And we have a firewall. So uh, firewall is basically a network monitoring system. It will detect the network based threats. So for example, if any of the IP was blacklisted as a cobalt strike, it will detect that IP and it will block that IP. Okay, so it will block that IP. Okay, so that was a primary responsibility of the firewall. It will see the network based threat. Okay, so blocking the IPs, URLs and all. So next we have IPS and the IDS, intrusion prevention and intrusion detection system. It will basically monitor your network packets, like what are the packets it was receiving. If you open a Wireshark, you can see a lot of packets, right? So it will investigate that packet, and it will monitor if there is any malicious executable or malicious behavior inside the process. Okay, sorry, inside the packet. Okay, so it will monitor the packet network packets, and it will detect that packet if it was malicious. Okay, so next we have a DLP. So it's a data loss prevention. So it was I already discussed when a ransomware threat actor, if there is a ransomware, they will use Orclone or some other third party tool for exfiltration, right? Data exfiltration. They will upload the data into the DLP, data leak sites, or any other cloud platform. The threat actor will do that exfiltration. So in that time, DLP will helpful to prevent that kind of exfiltration. Okay, so it will prevent the organization from the data exfiltration. These are the some protection system currently we have uh, in our world. Okay, so we discussed a few of the things. And if you need to learn more about the antivirus bypassings, EDRs, how the gates will work and how the hooking will work, and types of gates, these all the things you can find in the knowledge base section. So that video was very 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 useful if you are really if you really need a um, defense evasion related things. Okay, if you need a evading antivirus softwares and all. Okay, so I think I discussed a lot of things. And let I will think what are the other things to discuss. EDR, static engine, dynamic engine. Okay, LP, EDRs. Okay, yep, I discussed all the things. We will meet you in the next section. Yeah, my slide is also completed. We will discuss in the next video. Um, yep. Bye bye. See you in the next video. Thank you.